All right, welcome back, everyone, to the deep dive. Getting ready for these senior software engineer interviews, it feels like you need to know everything inside and out.
Yeah, for sure.
Like not just what things are, but all the whys, the hows, the what ifs. Like today's topic.
Oh, absolutely.
We're talking about something that seems basic, but it's way deeper than you might think at first glance.
You got it.
Object construction in programming.
Yeah.
Specifically constructors.
Right.
We've got some sources here that really dig into the nitty-gritty, especially about how objects get initialized. Kind of hinting at certain code examples without naming a language directly, which is cool because it makes you think about the core concept.
Yeah, the underlying principles, those are key.
So our mission today, let's call it a deep dive, is to get into that level of understanding that senior devs need to have.
Exactly. Because at the senior level, it's not enough to just know the syntax.
Right. It's about, like, okay, you wrote the code, but what were your design choices? Why did you do it this way?
Exactly. You've got to be able to explain the implications of your code, how it affects object creation, the whole life cycle, and ultimately how you build a system that's solid and can be maintained.
Yeah, that's the stuff that shows you really get it.
Right. And the principles we'll talk about, those apply across languages. It's not about memorizing the quirks of a specific one.
Okay, so starting with the basics.
Hmm.
What is a constructor? Really, I mean, we hear the term all the time, but what's its core job in the whole object creation process?
Well, put simply, a constructor is this special method, right? It automatically gets called into action when you create a new object using that new operator.
Oh, okay.
And its main job, it's all about setting up the initial state of the object.
Like initializing those instance variables, right?
You got it. Giving them their starting values. It's basically the object's setup routine.
So it's sort of like a regular method then, but with a special purpose.
Yeah, you're on the right track. The way you declare it looks familiar.
Okay.
You'll see those access modifiers like public or private.
Right.
And constructors, they can definitely have parameters too.
Sure, to pass in values.
Exactly. But there are two really important differences that set constructors apart.
Okay, hit me with them.
First one, the constructor's name. It has to be identical to the class it belongs to.
Gotcha. So like if your class is employee, the constructor's got to be employee too.
Spot on. And the second one, this is where some people trip up, is the return type.
Return type.
A constructor has absolutely none, not even void.
Oh, interesting. So it's not returning anything at all?
Nope. It's just doing its setup job.
That's a subtle point. What if someone accidentally puts void in there? What happens?
Oh, then it gets a little messy.
Okay, how so?
If you stick in a return type, even void, you're basically turning that supposed constructor into a regular method.
Oh, I see.
It's just a method with the same name as the class.
So when you use new, it doesn't automatically call this method anymore.
Exactly. It's no longer the special constructor. And that can lead to some real head scratching because your object isn't getting set up the way you think it is.
Yeah, that sounds like a sneaky bug waiting to happen.
Oh, absolutely. And the compiler might not even scream at you about it, which makes it even harder to find.
Yikes. Especially during an interview. That'd be rough.
Oh, yeah, big time. So we've got the new operator. That's our trigger for the constructor.
Right, like new employee and so on.
Exactly. But what's actually happening under the hood when we do that?
Yeah, walk us through it.
Okay, so picture this. You write something like new employee, Alice, 60,000.
Okay, creating the new employee object.
Right. So the first thing new does is it goes out and grabs a chunk of memory.
Memory.
Yeah, on the heap. Enough space to hold all the information for this new employee object.
Okay.
Then it hunts down the right constructor for the employee class.
The one that matches the arguments we gave it.
You got it. In this case, the one taking a string and a double.
Right, for the name and salary.
Exactly. The constructor runs its course, sets up all the instance variables, and then new hands you back a reference.
A reference to what exactly?
To that freshly baked object you just created.
Ah, okay.
Sure.
So we can use that reference to do stuff with the object.
Precisely. You usually store that reference in a variable so you don't lose it.
Makes sense.
Like employee Alice evil new employee. Alice, 60,000.
Right, so we can say Alice.do something later on.
You got it. Or you could pass that reference straight to another method.
Oh, okay.
Maybe you're adding this new employee to a list, like an array list.
So something like staff.add new employee Bob 70,000.
Boom! Exactly like that. The point is, new gives you the key to access and work with that new object.
Now, in the real world, you don't always have all the info up front when creating an object, right?
For sure.
Sometimes you might just have the salary, but not the name yet, or vice versa. How do constructors handle that kind of flexibility?
That's where constructor overloading comes in. It's a super handy concept.
Overloading, like with methods.
Exactly the same idea. You can have multiple constructors in a class, all with the same name, but they take different sets of parameters.
Oh, I see. So like one constructor takes the name and salary, another takes just the salary and so on.
You got it. Makes object creation way more flexible.
Can we stick with the employee example to illustrate that?
Absolutely. Let's say you want to make an employee, but only have the salary right now.
Okay.
You might want a default name for now, maybe an empty string.
Right. Just to have something there.
Exactly. So you define a second constructor like this. Public employee, double salary.
Okay. And inside that constructor, you'd set name to an empty string and salary to the value passed in.
Precisely. Now you've got two constructors for your employee class. One that takes a string and a double, and another that just takes a double.
And how does the code know which one to use?
Easy peasy. When you write new employee, Charlie, 80,000,
Yeah.
the compiler sees you've got a string and a double, so it picks the first constructor.
Okay. Makes sense.
But if you just write new employee, it knows you only have a double, so it calls the second constructor.
Oh, so it just matches the arguments to the right constructor.
Precisely. It's all based on the number and types of arguments you provide during object creation.
That's clever. It's just like method overloading, where the method signature determines which version gets called.
Spot on. And because constructors always have the same name as the class, overloading them is super common.
Yeah, it makes sense to have different ways to initialize an object.
Exactly. It gives you that flexibility and convenience that's so important in good software design.
So we've got multiple constructors potentially doing different setups. What if there are some common steps you want to do in all of them?
Ah, good question.
Like we don't want to repeat the same code in every
Right.
single constructor, right? That'd be a nightmare to maintain.
Absolutely. Code duplication is a big no-no, especially in larger systems. It makes things harder to read, harder to change, and just plain messy.
Right, so what's the solution?
Constructor chaining to the rescue.
Chaining. What's that?
It's a neat trick where inside one constructor, you can actually call another constructor of the same class.
Oh, interesting. So you can sort of delegate the work.
Exactly. It helps keep your code clean and organized.
And how do you do that in code?
You use a special keyword.
Yeah.
It's like saying, hey, go run this other constructor first, and then I'll do my thing.
Okay, so back to our employee example. Let's say our main constructor, the one with name and salary, has some essential setup code.
Right, something every employee needs, regardless of how they're created.
Exactly. So how would we chain our salary-only constructor to this main one?
You'd write it like this. Public employee, double salary.
Okay, so we're calling the name and salary constructor from the salary-only constructor?
Precisely. And notice that this food salary is the very first statement inside the constructor.
Why does it have to be first?
It's all about order. You want those core initializations to happen before anything else in that specific constructor kicks in.
Right, so we don't accidentally use a variable before it's properly set up.
Exactly. Plus, it's important to remember that this, in this context, is not referring to the object itself.
Oh, right. Usually this is how you access stuff within the object.
You got it. But here, it's a special keyword just for calling another constructor.
Okay, so it's like a different flavor of this. Now, what happens if we completely forget to initialize an instance variable in any of our constructors?
Good question. You might think it just stays uninitialized, right?
Yeah, that'd be kind of scary.
Thankfully, that's not how it works. The system has your back, in a way.
Okay, what happens then?
If you don't give an instance variable a value in a constructor, it automatically gets a default value.
A default value, like what?
It depends on the type of variable.
Okay, break it down.
For numbers, like int or double, the default is 0.
Makes sense.
For booleans, it's false.
Okay.
And for object references, like our string name example, the default is null.
No. That could be a problem, couldn't it?
It can be, yeah. Think about our employee example.
Okay.
If we have the constructor that takes just a name, and we don't explicitly set a salary.
The salary will default to 0.
Exactly. Which, depending on your app, might be fine.
Sure. A starting salary of 0 could make sense in some cases.
But if we use the constructor that takes just the salary, and we forget to initialize the name,
Then name will be null.
bingo. And that can lead to trouble down the line.
Right, because if we try to do something with that name later on, like compared to another string.
You're going to hit a null pointer exception. It's a classic programming error.
Yeah, not fun to debug.
Not at all. Especially in a complex system, those can be tricky to track down. It's a good reminder that instance variables and local variables behave differently.
How so?
Local variables, those declared inside a method, you have to give them a value before you use them.
Oh, right. The compiler yells at you if you don't.
Exactly. Instance variables, the ones tied to the object, they get those defaults.
Which is convenient, but can also be a trap if you're not careful.
Precisely. I remember once debugging this bug, it was driving me crazy.
Oh no, what happened?
It was these random null pointer exceptions happening deep within the system. Turned out it was all because of a missing initialization in a constructor. It was a tiny oversight with huge consequences.
Ouch. It really highlights how important it is to be explicit about initialization.
You got it. So constructors, they're our main way to set up instance variables. Are there any other ways to give them initial values?
Yeah, the sources mentioned a couple of other things.
Right. One way is to directly assign a value when you declare the variable in the class.
Oh, okay. Like right there in the class definition.
Exactly. For example, you could write private string name.
So setting name to an empty string right from the start.
Precisely. And this happens after the object gets its memory space, but before any constructor runs.
So no matter which constructor is used, name will at least start with an empty string.
Exactly. Of course, a constructor can always overwrite it later if needed.
Right, it's just a starting point.
Yeah.
But what about those initialization blocks? I remember seeing that term.
Ah, yes, initialization blocks. Those are basically chunks of code inside curly braces that live directly within the class definition.
But outside of any methods or constructors.
Exactly. They're kind of like setup code that runs before any constructor.
Oh, interesting. So they run first, no matter what.
Well, they run in the order they appear in the class, but always before the constructors.
So they're like a way to do more complex initialization that doesn't fit neatly in a single line.
Precisely. Like, let's say you want to give each employee object a unique ID.
Okay.
You could use an initialization block to generate a random number or grab the next ID from a sequence and assign it to an instance variable.
Makes sense. But are initialization blocks commonly used?
They're not as common as direct initialization or doing the setup in constructors.
Why not?
Well, if the logic gets complicated, it's often better to put it in a separate private helper method.
Oh, I see. So keep the initialization blocks for simple stuff, and for more complex logic, just call a helper method from the constructors.
Exactly. It keeps the code cleaner and easier to understand. Now let's talk about those final instance variables.
Right, the ones that can't be changed once they're set.
Exactly. When you declare a variable with final, it means it must have a value by the time every constructor in the class is done executing.
Okay, so you have to initialize them in every single constructor.
Precisely. You can either assign a value directly when you declare the variable, or you can set it within the constructor's code.
So if we have private final string name, we have to make sure name gets a value in every single constructor of our employee class.
Exactly. This is common for properties that should never change after the object is created.
It's like saying this aspect of the employee is set in stone.
Precisely. But there's a nuance here when it comes to final references to mutable objects.
Mutable objects, like an array list.
Exactly. In this case, final means you can't change the reference itself.
Okay, so the employee object can't be associated with a different array list later on.
Right. But you can still modify the contents of that array list. You can add or remove elements from it.
Oh, I see. So the reference is fixed, but the object it points to can still change.
Precisely. It's a subtle but important point, especially when discussing immutability in a senior level setting.
Makes sense. Now let's shift gears to constructors that don't take any arguments at all.
Those are often called no-argument constructors or sometimes default constructors.
Okay, and we can explicitly define them in our class.
Absolutely. Like
Yeah.
you could have public employee salary, it allow.
So you're basically setting default values for the instance variables.
Exactly. It gives you a way to create a basic employee object with some predefined values.
What if you don't define any constructors at all in the class?
Ah, that's where the compiler steps in and helps you out.
Okay, what does it do?
If you don't write any constructors yourself, the compiler will automatically provide a no-argument constructor for you.
Oh, so you always have a way to create objects, even if you don't explicitly define a constructor.
Exactly. This auto-generated constructor is often called the default no-argument constructor.
And what does this default constructor do?
It's pretty basic. It just Initializes all the instance variables to their default values.
So 0 for numbers, false for booleans, and null for object references.
You got it. Or to any values you might have given them when you declared the variables.
Right, like setting name to an empty string in the class definition.
Exactly. So even without writing any constructors, you can still use new to create objects.
But there's a catch, right? What if we define even one constructor, even if it has arguments?
That's a crucial point. If you define any constructor yourself, the compiler will not generate that automatic no-argument constructor for you.
Oh, so you lose that safety net.
Exactly. So if you need a no-argument constructor in addition to other constructors you've defined, you have to write it yourself.
Gotcha. It's like the compiler says, okay, you're taking control now, I'm not going to assume anything.
Precisely. It's a detail that interviewers might throw at you to test your understanding of how the language works.
Okay, so it's good to be aware of that quirk. Lastly, the sources touched on something called finalization.
Right. Finalization is a mechanism that some programming environments provide to run code when an object is about to be garbage collected.
Garbage collected, like when the system decides the object is no longer needed.
Exactly. Java does have this finalization feature, but it's generally considered a bad practice to rely on it.
Why is that?
The main problem is that the timing of finalization is unpredictable. It depends entirely on when the garbage collector decides to clean up.
So you can't guarantee that your finalization code will run when you expect it to.
Precisely. There are much better ways to manage resources, like using try with resources blocks for things like file handles or network connections.
Okay, so for the purposes of senior level discussions, finalization is not something we need to dive deeply into.
Exactly. Focus on proper initialization through constructors and using reliable techniques for managing resources.
All right, so let's do a quick recap of this deep dive into object construction. Constructors, they're those special methods, same name as the class, no return top, called by new to set up our objects.
Right.
We can overload them to have different ways to create objects. We can chain them together to avoid code duplication. Instance variables get default values if we don't set them, but watch out for those null values.
Definitely.
We can also initialize them directly in the class definition or use initialization blocks. Final variables must be initialized in every constructor, helping us with immutability. And lastly, that automatic no-argument constructor, it disappears if we define any constructors ourselves.
That's a great summary. Knowing all this, not just the what, but the why, is crucial for senior roles. It shows you think carefully about object creation and its impact on the entire system.
So, to leave you with something to think about, how might understanding constructors at this level influence your design choices? Especially when you're building complex systems and need to think about immutability and making sure objects are managed properly throughout their life cycle. Think about those real-world design scenarios and how these principles can help you write better, more robust code that's less prone to errors. That's all the time we have for today's deep dive. Thanks for joining us.
Thanks for having me.